Hello and welcome to week 8. We have a guest tonight. We've got the baby who's here to learn SQL, do some coding. All right. So before we begin, any questions, comments, thoughts, concerns from last week's lesson, or anyone have any questions, comments, concerns about the final project? I have to check something here. Someone put a question in the announcement. I need to check that question on the announcement real quick. Okay. Nothing? Everyone good? All right. So someone asked a question. So you normally if people can't be here, ask them to put the questions in the chat or on the comments. So a question was asked from Carlos. How you doing, Carlos? Hope you're doing well as you're watching this at home or wherever you're at. I was wondering what the specific workflow is and what the specific responsibilities of each role when a team or enterprise has a database administrator. How does this person work with software developers? For example, if a team of developers needs the database to support a new feature or change, do they work directly on the database themselves, or do they request a database administrator to make those changes? Is that how it typically works? That is a fantastic question. So let's start with that today. What is the job and responsibility of database administrator in a team of developers? So in the perfect world, what happens is the developers figure out something that they want to do, and they have to make changes to their front end of their application. If they need to go into the database, they work with or they collaborate with the database administrator to tell them the change they made. The database administrator would then work with them to create the code for those changes and then apply the changes there. Because in the world of databases and programming, there's what do we call it? There's path to production, which how do we get something from non-production into production? And there's also delegation of responsibilities. When we're in a world where we've got developers and a production environment, we generally do not allow developers to touch a production environment because developers, God bless them, will sometimes make mistakes, which is ironic because we're going to talk about making mistakes tonight and how to fix them. Um, so that's what happens in the perfect world. Developers decide what their changes. They work with the database administrators to figure out what the code is. The DBAs write the code, and then it gets put into the tested in development, goes into QA for load testing and user acceptance testing, and then into production for the world to see. How it really works. There's a development environment. The developers do what they want there because it's their environment. They can write the code that they want. They can mess with it. They can change it, whatever. They can do what they want to do. When the time comes to bring it into QA, they'll work with the database administrators. They'll extract the code out. They'll give it to the DBAs. The DBAs will review the code to make sure that it's supported by the structure. So we just had that happen in our job, in my day job. We've got a database that's a data warehouse. And what a data warehouse is, it's a lot of data from a bunch of different sources in one database, essentially. It's think of like a Costco, if a Costco is a database. Okay, so you've got your frozen food, you got your vegetables, everything's there. So, and it's the way it's built in there, the databases and the tables are built in such a way to support the queries that get asked against it. And how does a database support the queries? Well, it's how the indexes are built and how the constraints are built. And we're going to talk about indexing and constraints either next week or week after next. I forget, it's one of the two. Probably not. I think it's probably next week. Nope. It's week 10. Next week is views. So when the indexes are built, they're built on the columns that you should search on. Developers may or may not know the best way to write a query, and the best way to write a query is to make sure that your where clause and your from clause and your where clause and any on clauses you have in there are supported by the indexes. So the developers do what they want in non-prod. There's no load testing. They just make sure it works. And then it's gone into QA. And in QA, the DBAs will review the code. to make sure it meets the criteria it needs to move into the environment. Upon accept, she's stealing your switch. Are you okay with that? Okay. I don't know if you saw her or not. Uh, so the DBAs will review the code. They'll let them know if it's okay. They'll put it into QA. They'll have the user acceptance testing and the load testing, which means you get a batch of test user go in, make sure it does what it's supposed to do. They run a load test. There's a bunch of applications that say, I want to see how this application responds if like 500 people are using it at the same time. And when it passes all that stuff, it then moves into production. And that's how that works. So that is how it typically works. For the most part, database administrators aren't developers; they're administrators. They make sure the backups are running, the indexes are, the maintenance and things like that. They're not the they're actually database developers, application developers that work in that case. So to answer your question, Carlos, typically developers do what they want dev, then they would work with the DBAs to move through the process of QA and prod. All right, make sense for everybody? Sweet. All right. If there are no other questions, let's go to this week's code. Where's my share screen? There it is. All right, share screen. Just share it all. Share. All right. Here we are. So today we're going to focus on how to make sure we protect bad things from happening. We don't want bad things to happen in our database. We don't want end users coming in and doing something silly. There's a term, I don't know why. So there's a term that's brought up. It's called ACID: atomic, consistent, isolated, and durable. So a transaction is any series of code executed against the database. Now that could be like 12 select statements, 3 delete statements, 2 update statements, and an insert. Run it once, it's one transaction. So when we talk about creation of transactions, we want transactions to be atomic, consistent, isolated, and durable. Meaning atomic, it does one thing. You want to yeah. How annoyed are you when you're in line at the grocery store and the person wants to buy groceries and also wants to get $20 cash back and also wants to get a pack of stamps and also wants to talk to the manager and also wants everything bagged, double bagged in plastic and then in paper. So that's multiple transactions. And this is very sad making. We want one transaction. So we want a query that we write to have one transaction, one thing that does one thing. Consistent. It does it the same way every single time. When we write queries, generally speaking, for an application, they're going to be run multiple times. It's not just a one-time deal. If we have a query that gets all the movies for a customer based on a topic, that's going to be run multiple times in the application. So we want to make sure that every time it's run, it gets the same results. Isolated means it works on its own. It's not dependent on anyone else. And if it is, it's a very restricted dependency. And durable means it ain't going to break. Now, durable is hard because there are people who make mistakes and break databases. So we've got to, encounter for that. But whenever we create a transaction, this is going to be talked more. So next week, we're going to talk about how to create stored procedures, which is nowhere in this course, but we're going to talk about it anyway, because we're going to talk about views. So we need to talk about stored procedures. That's next week. But what a stored procedure is, it's a permanent query that you write. So in that case, those are even more importantly, they need to be atomic. Okay. So like I said, today we're going to talk about transactions in a sense, but we're going to talk about how to protect those transactions from something bad happening to them. There's a couple different ways we're going to do that. There's a couple things we're going to try, and they may not work because I'm not sure if they're going to work in MySQL, but we're going to give it a shot. But I'll explain to you what should happen if it doesn't happen. Okay. So we have this command here at the start called start transaction. Okay. What this means is, so if I ran these on their own, they would run. They would do it. They would run in a transaction. I've highlighted, they've run, boom, they'd be finished. That's what we called an implicit transaction. It's implied that it's a transaction because I've run the stuff together and that's a transaction. When I issue this command start transaction, this becomes an explicit transaction. I've explicitly said, here's a transaction. And the reason I do this is because when I have an explicit transaction, I can control what's happening before it finishes. Okay. So here, I'm going to go ahead and start this transaction. Okay. And then I'm going to delete from film. First of all, I'm going to delete from actor where actor ID is 1. And I'm going to move this out of the way because I want to show you something. So I'm going to do this first. And I got an error. It says cannot delete or update parent row. A foreign key constraint is stopping it. So what this is saying is if I try to delete from actor, it's not letting me do it because there's a foreign key to another table. So foreign keys or keys in general are there to protect consistency in a database. So I can't go here. So in film actor, this table connects the film table and the actor table and it tells me what actors and what films. If I were to delete actor from here and not from here, it would orphan all those actors in the film actor table. So film actor 1 would have no longer have a relevancy. So that's what we call dirty reads, meaning there's data in the database that doesn't connect to anything else. So we protect against that using foreign keys, which we've already talked about. This is them in action. So I can't delete from actor until I delete from film actor first. So I'm going to go ahead and run these both here. And so now I've deleted 19 rows from film actor and 1 row from film actor. So when I run this here, I have no rows for actor ID 1 in actor anymore. Because I set this as an explicit transaction, I've got 2 commands I can issue. One is rollback and one is commit. Rollback changes everything back. Commit keeps it as it is. Okay. So I'm going to roll this back. Now I'm going to talk real quick on how this happens. So do y'all remember a couple weeks back when I was talking about the right ahead transaction log? Do you remember that? Mary, you weren't here, so I'll do a quick overview on it, okay? So this is my database here. Here is my end user, okay? When I write to a database, I don't write directly to that database because that can be a problem. So if I'm writing to this database directly and I'm updating 10,000 rows and the connection and my Wi-Fi drops after 5,000 and I'm writing directly to that database, this database doesn't know that the transaction didn't finish because it died beforehand. So when it comes back up, it's like, hey, we're good to go, and we're not because we're missing a bunch of data. So what they did to make sure that this doesn't happen is they created something called a transaction log or a T log. So whenever something writes to the database, it first writes to the T log, and the T log then writes to the database. So if I'm updating 5,000 rows, right, or 10,000 rows, and it goes in here, it starts writing the rows here. And every row gets what's referred as an LSN or log sequence number. So once it reaches a point where it's okay, it starts sending the things over to the database. Once it reaches, so it buffers in. So let's say it starts buffering once 1,000 rows are reached, right? So it's here, la la la, it says LSN. So it says the transaction says, hey, transaction log, I got 10,000 rows, LSN 100 to 10,100 is coming in. There you go. So the header of this says 10,000 rows, 101 to 10,000. Here we go. So it starts writing, boom, 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 boom. Then it starts writing to the database. If for some reason the database goes down, after 5,000 rows, right? It comes back up. And the first thing it does, it looks at itself and says, hey, I feel incomplete. Something's not right. I died in the middle of a transaction. And it'll say, hey, transaction log, I see you sitting over there. The last LSN I got from you was 5,632. What was I supposed to get? And the transaction will go, hey, you're supposed to get to 10,000. And then a decision has to be made. If in the transaction log are the remaining rows up to 10,000, the writing continues and the 10,000 written are written. As soon as it starts back up, the rest of the rows are carried over to the database and it's like nothing ever happened. If for some reason the transaction log doesn't have the missing rows, it rolls back the changes and goes back to 100. Does this make sense? Okay. So let's take this a layer deeper now. So let's look at what happens between the database, the data, the user, and the transaction log. Now, you remember that I said, no, I've never said this before. So let me say so everything is here. So no, you remember I said that nothing happens on the drive, everything happens in RAM, right? Because you cannot, if it's on a hard drive, you can't touch it. It's got to be in the active RAM so it can be manipulated. So what happens here is, so in the RAM of the computer here, or in the RAM of it'll either happen on the laptop or the computer that's doing it, or on the server that's running it. In the RAM, let me bring the RAM space here. Let's do this to RAM. So this is the RAM. What happens is this. When the application writes to the transaction log, it writes to the RAM first. Okay? So what happens is, and remember how I said when it runs the query, it pulls the table from the database down into RAM? Okay? So that table exists there. So if you're just doing selects, that's what happens. It just grabs the table, does its selects, goes away. If you're doing an insert, update, or delete statement, okay, what happens is within the RAM, it creates two tables. Those tables are copies, empty copies of the tables you're trying to insert, update, or delete into. Okay? One is called inserted. This is like super deep doctrine here. So one is called deleted. Okay? I'm just trying. So what happens here is when the application is trying to insert something, first it inserts it into the inserted table. That's an empty copy of the original table. So let's say it was into actor. So this insert table is a copy of the actor table, which means it has all the constraints, all the columns, all the data types there. So what happens here is when the application writes to the database, writes to this, it writes to the fake table first to make sure the data that's going in actually works. And then when it's satisfied here, it goes there into the T-log, and then from the T-log into the database. If you're doing a delete statement, it attempts to do the delete statement and it puts the deleted rows in the deleted table. And when it makes sure that it's worked, then the deleted table then does its thing and goes to T-log and then goes to the database. Okay. And if I do an update statement, it does both. It writes the changes to inserted and gets the deletions to deleted. And then the two of them together write to the T-log and then to the database. Does this all make sense? It's not critical that you understand it. It's just a theory on how things work. So this isn't on a quiz. This is just me, imparting some knowledge that you're never going to get anywhere else because no one ever talks about this stuff. Okay. So when you're doing transactions, right, what happens is you go to the database and say, hey, I'm going to work on this table right here. I'm going to start a transaction on it. While I'm working on this table, no one else can touch it. No one else can insert, delete, or update on it. Because once I start that transaction, any table I use goes into a locked state. The reason why it goes into a locked state is because we don't want people going in and looking at the data while I'm in the middle of changing it. So if I'm updating back into this example here, I've got a transaction, I've got this table locked, right? I don't want something coming in reading this table while I'm trying to change it because they're not going to get all the changes. If I'm doing a update to the prices in my inventory and I'm doing a 10% increase, right? And someone grabs the data out of there before the update is done, they'd have the wrong price. And I don't want that to happen. So whenever I do a transaction, it locks the table. The other reason why we want ACID compliance in our queries is because since we are locking that table, the change cannot take long enough to disrupt the service for the customer. So we've got to make sure our queries are ACID compliant because then they're going to take milliseconds and no one will know what's going on. Okay. So back to the code here. So when I have this here, okay, I started my transaction. Sure, roll it back here. Is this back? Yeah. I start this transaction. All these changes are made. Nothing's written to the database. Okay. Nothing's written to the database until I say commit, and then it goes. If I say roll back, it goes, it's in the transaction. It goes through insert and deleted the tables in RAM, and then goes to the T log, and then it's waiting there. And if I say roll back, it just erases it. What's up, Mary?
What's the point of doing a transaction if you're just going to roll it back anyway? Like, is it just so you can see it?
Right. So let's say let's go to this one over here. Okay. I need to update the film table. I gotta set the title to a new movie called Everything is the Same. Right. So it's just after lunch. I've eaten a lovely bowl of pasta and turkey, and I am sleepy, and I'm not paying attention to what I'm doing. So I go here, and I'm smart enough to start the transaction beforehand. And then I'm like, okay, let's go and it's supposed to be film ID 6, and I just run this instead. And all of a sudden, I've accidentally changed every title to everything is the same. If I had not run that transaction to start, um, I'd be in a lot of trouble right now. But because I did, I can roll it back. Using the transactions to do things like this, um, is a way to make sure that the changes you're doing are correct before they go into the database. It's also a way to do error handling. You can start a transaction and update it, and you can say, if there's an error, roll back. If there's no error, commit. See? So this is indemnity of you making a mistake. When I when my first job as a DBA, I worked for this company and I had to make a change to a database and I ran it without the where clause and it changed everything in that database. And I had to fix that and I didn't use start transaction. So I had to go back to a backup. The database was down for like 45 minutes. I had to pull a backup up. I had to recompare the tables and fix it. Luckily, it was fixable. Okay. So that's why you would do it this way. So let's get a little fancier here. Okay. I've got this query here. I'm creating a table And I have normally create table just looks like this. Create table bank accounts. But I put this if not exists. And this, because if I ran this, create table, it will create a table. If we try to run it again, it's going to say, hey, dummy, it already exists. So if I had a stored procedure that was built that created a temporary table, right, that I just wanted to use for the purpose of that particular transaction, and I created the table in the stored procedure, created the table and didn't drop it at the end, it would cause a problem, right? So if I add this to it and run it, it just gives you a warning that already exists. It's not an error. It's just a warning. So it doesn't crash it out. So I can put this in here, if not exists, to ensure that if I try to create something that already exists, I will be warned that it's already there. And it won't run. It'll say, hey, we didn't run it. So here I'm just going to insert two quick values into that. Okay, so I'm going to select star from bank accounts. Okay, so I got Alice, I got Bob. So here I'm going to start a transaction. Now, in this case, I'm setting this up so both have to succeed for me to commit. And it's just me paying attention to it. We're not gonna get into the code of doing that right now. So here I run both of these. My transaction is set. I don't run the commit just yet. There we are. Run that. Check out that everything worked fine. Check my bank accounts. It's correct now, and I can commit. And now that's a permanent change. Okay. So here, this is what I kind of talk about. This is like we're not going to have a crash, but let's say I run this, I start the transaction, and the power goes out. So or constrained, if something went wrong. I don't want this to stay there because it everything else that was supposed to happen didn't happen. So when it comes back up, it rolls back the change. So I've often referred to databases as self-healing. And it's sort of an accurate description because it can't do it on its own just because no matter what AI says. Did you all hear this? You know AWS, right? Amazon Web Services. It's Amazon Web Services. So, did you hear that last week it went down for 3 days because the AI they have running it decided the code was bad and shut it down and rewrote the code for 3 days. So AWS services are down for 3 days. Yeah, let's keep those cloud solutions going. Let's see what happens, right? All right, sorry, I described there. So then we roll this back. Okay. So let's get a little fancy. These I'm gonna have to run all at once. Okay. So here, now remember when I said um that whole thing about the when we were just talking here's about that this whole inserted table. And so here's where this comes into play. So I'm running this transaction and I'm inserting into rental the rental date, the inventory ID, the customer ID, and the staff ID. The rental date is now, and then inventory ID is 10, customer ID is 5, right, staff ID is ID as is 1. Notice there's no rental ID, but that's being inserted because the rental ID is an automatic. It's automatic numbered, right? So how do I know what that ID is? Because I've got the payment table here and I want to put that rental ID in there. So when when something is inserted into a database, it's written into this table here. And if there's a column that's automatically numbered like rental ID, it's here, right? And so we have a predefined variable called last inserted ID. Okay. So that's why I have to run this all at one time. So when I run this all at once, okay, it's going to insert into the rental table these values. It's going to grab the last rental ID from the inserted table from this function here, and then it's going to take that rental ID and put it into the payment table.
How does it know what, like, where to get the last insert ID from, like which table it is, because there's no from statement.
Right, exactly. So remember what I said over here, I've got this inserted table, right? So
Okay.
because I'm doing an insert table, it knows it inserted into rental, right? And because I'm in a transaction, it never made it to the database. So it's all happening within this transaction. So as soon now, keep in mind when I say last insert ID, I'm only inserting one row here, right? So there's only one rental ID that's being done. So when this is done, that rental ID is floating out that inserted table in RAM. This clause, this function here says, hey, go to the inserted table and get me the last thing that was entered there. And then it knows what it is. And this is creating a variable here. Set, you just the @for sign tells it's a variable. Set the last rental ID variable to last inserted ID, and then inserting it here into last rental ID. Now, if I were inserting 50 rows into the table, it would only give me the last ID, the 50th row that was put in. Okay. So I'm gonna do here. I'm gonna do select at uh, last rental ID. Okay. And because this is doing this with the rental ID, I have to run this. If I run this and then this, it may not work because it kill. If I run this by itself, well, since I'm in a transaction, it shouldn't. But if I ran that by itself, it would kill the transaction as soon as it was done. So if I run all this at once, okay, that's the rental ID, 1650, and it inserted into payment. So if I do select from payments, where rental ID equals that, I do wrong. Oh, six star. Oops. Okay, there. Okay, that's where it is. That just happened now. Okay. If I roll it back, that's that. It's done, but I'm going to commit it. So now it's there forever. Okay. So there's a lot going on here with this one. So we're getting to like, a lot of complicated things. We're inserting into it. We're in a transaction. We're inserting into a table. We're grabbing the last rental ID, that last ID from that table that was inserted, and then using that to put into the payment table and then committing that. So you can see why it's important for this to be in a transaction because if the insert failed, the payment would fail. If the insert into rental succeeded, but the insert payment failed, we would never know that the guy paid for the video. So we have to bind these together into a transaction that are run at once. So
I have
here,
another question about transactions and inserting stuff into the table.
Sure.
So for our final project, we have um like we reverse engineer like all the tables and everything, but then when
Mhm.
we're inserting actual values, can we like do we have to hard code that or can we do it in the EERD or the
So you actually
whatever it's
have to
called?
you actually have to write the code for that. You can't put data into an
Okay.
ERD. So what I suggest you do with that, I don't know if you heard me say this, but what I strongly suggest you do is get your favorite AI engine and give it your that the code you get when you reverse engineer it, give it that code. And then say, hey, write me, please write, always say please. Because you never want you always you got
Yeah.
to make sure the AI doesn't want when they take you on they like you like Mary's a good person, we're not going to kill her. So say,
Hmm.
please write me 10 insert statements for every table in this database, and it'll just spit it out for you. So that's I'm totally okay with you doing that because writing if you've got 10 tables and you're writing five insert statements, that's 50 insert statements. Why would I do that when I can have someone do it for me?
Hmm.
Right? So with that. So you can do that. Okay. So here I got this transaction here. I'm inserting to the rental table. And then I'm updating that. Now, I'm inserting the rental table where the rental inventory ID is 15, right? And I want to update the inventory to now where the inventory is 15. So the last time the inventory was checked, with that last time the inventory was used was today. And again, we're putting this into a transaction because I want to make sure if this fails, this doesn't try to run. It won't because I know they're both there. So we'll start the transaction and run that. Worked fine, and I'll commit it. But again, the reason for these explicit transaction, one of them is to ensure data sanctity, the preservation of data. Now we've got something else we can do. Let's say we're uh, doing a bunch of updates on a table, and we have a lot. We have a transact. There are a lot of updates going on at the same time. But I want to be like I don't want it if one thing fails, they all fail. I want to have some ability to control that. I've got a command called save point. Okay, so here I can start the transaction. Right? Let me make sure I committed this one first. Okay, so I'm gonna start this transaction, and then I'm gonna run these two. So I'm gonna insert into actors where the values are first and save, and I'm gonna save it to stage one. So this makes a point where I can roll back to. It's a save point, like in a video game, and it's called stage one. So if I run some more stuff, and here I go, let me run this one, and I insert, and I go, oh no, that's not what I was supposed to do. I can roll back to stage one. So everything in stage one has happened, and everything past that hasn't. Right? So again, there's a lot that we can do to control the data that goes in there and to make sure that it goes in right and we can protect what we're trying to do. And we'll just roll this back because I don't want to keep first last. There. All right. All right. So here, these two. I'm just going to do this one because I'm not sure that this is going to work. So ideally what's supposed to happen here with this one is the second I start the transaction and I use this for update command at my select statement, right? It's basically telling the world, you can't touch this table because I'm about something to do something to it. So I'm going to start my transaction. And then I'm going to run this. Okay. So now I've updated a bunch of stuff and I'm in the middle of a transaction. If I go over to here and I've got a command that's I want to update the film table. So over here, I've locked down the film table. So if I go over here and run this, okay, it shouldn't have let me. It let me though. So in other databases that are more protective, the second I did that, it would have said you can't do this because that table is locked.
And you locked it with the for update statement?
Yeah, yeah, that should have locked it. But in MySQL is not as robust database engine like Microsoft SQL Server or Oracle. Matter of fact, in Microsoft SQL and Oracle, you don't have to use this for update statement to stop it from using anything else. It just once you're in the middle of a transaction, nothing else can touch it. So when I roll this back and I select from film, it rolled everything back. Even the change that I made here. Because I changed that to broken link too. All right, let's look at these. Like we've already done one like this. I'm inserting a rental. I'm getting the last insert is that one I've already done. That's fine. Um, None of these are different. So the only we're at 1016. So there's one I want to show you here real quick. So um I'm gonna go back up to this bank data one here. Where do you go? Bank accounts. Okay, it's bank accounts. Okay. So uh oh, that's fine. Okay. Okay, so um if you remember on the first day when we were talking about DDL and DML, I said okay. I said that's right. That everything gets written into the transaction log. Okay. Except for one thing. So what I just did was I deleted both rows from the bank accounts table using the delete command, but I rolled it back and everything was fine. Okay. So when we talked about DML data manipulation language, there was select, there was insert, there was update, there was delete, and then there was this guy, truncate. Now, truncate has a different, we talked about the other day. Truncate gets rid of spaces and things, but truncate's got another function. And this is the dark evil one that you don't ever want to use. So here, like I just did, I ran my start my transaction. I deleted my rows. I select my rows. I roll back. They're back. They're back. Right? Okay. I start my transaction. I truncate my table of bank accounts. I do my rollback. It's still empty. So here's the difference. Remember when I talked about the T log here, right? Whenever I do an update, insert, or delete, every row that I've changed, inserted, or deleted is recorded in the T log. So if I delete 10,000 rows from a table, that transaction log is going to have 10,000 entries, deleting one row each. It seems a little overhanded, a little heavy-handed. but there's a reason for that. So let's say the transaction log is actually viewable. You can select against it because it exists. There's queries to you can't do it in MySQL, or I would show you. In your Oracles and in your Microsoft SQL servers and your Postgres DBs and your Mongos and all other things, you can select against the transaction log. So let's say you deleted 10,000 rows because the developer said, "Hey, Mary, please delete these 10,000 rows for me." And you're like, "Sure, here it is." I write the query, I delete the 10,000 rows. And then the developer goes, "Mary, I screwed up. I need rows 16 and 32 back." You can actually go into the transaction log and get those back. You can restore from the transaction log granular, like one row at a time, or you can just like restore everything, restore the data back to where it looked like at 3:30 p.m. Okay. So the point I'm making here is anytime we run a query against an insert, update, or delete statement against a database, every row transaction is recorded in the transaction log DB and is recorded with an LSN, and we know what it was. If we run truncate, it don't do that. Truncate is flushing the table. It deletes it without recording it to the transaction log. So there's no way to roll it back. So if you
Is
truncate
that,
it,
sorry, is that equivalent of just not even starting a transaction at all, just like running delete?
yeah, it would be like, well, no, well, yes and no. So if you ran a delete without a transaction, without a start transaction, you can still get the stuff back because it's in the transaction log. Okay,
Even without start transaction?
even without start transaction. So if I delete 1,000 rows without start transaction, every row is still recorded in the transaction log. Okay, so I can still go get it back. The point I'm trying to make is when you do a truncate table, there's no coming back from it. It's like if you drop the table, even if you drop the table on a transaction, I think if you let's find out. Let me see something. I'm curious. I guess if I remember correctly, I'm gonna put my stuff back in my table here. So go back here and where do I go? Oh, no, there it is. Select stuff from bank accounts. Okay. So if I do drop table, okay, I start my transaction. I drop the table. I try to select from it. No, no such table. I roll back and oh, so drop doesn't work. So you can't, yeah, because transaction is DML, so you can't do that, and that's fine. So so truncating the table deletes everything quickly without recording a transaction log. Why would you do this? Well, let's say I had a table that was a temporary table that I filled in with a million rows from somewhere else, and every day I refresh that from somewhere else. So I've got this table that every day, okay, let's say we're in the bank account thing, right? They're in the rent table. Every day at the end of the day, I run a query that takes all the rentals from the day and puts it into a table. And I use that data to do my nightly processing, right? And because I'm a chain store, I've got like 30 locations and it pulls in from all the databases. That table has 10 million rows in at the end of the day. If I want to empty that table out quickly, and I did delete from table and just delete everything, it would do one row at a time until it hit all 10 million rows, right? And I don't care. If this table dies, I don't care, and I don't need to recover it. So I'll use the truncate tip function there. So it's there for that. But I point this out specifically when talking about transactional rollbacks because that's the only function that you cannot come back from. Once you do it, you do it. All right. Alrighty. That covers all the stuff for today. Um, Now, I don't know if y'all have noticed or not, but the code we're talking about now isn't from today's lesson. Actually, the lesson with the code from week 8 we talked about 2 weeks ago. So right around week 4, we start working because the code we talk about next week in week 9 isn't until week 13. And I do this because the last in-person meeting we will have is week 10. So the Tuesday meetings will stop after week 10. Week 11, 12, and 13 are I'm available if you need me for your final projects. Plus, if I don't get all the code done by week 10, while you guys are trying to figure out how to write the code for your final project, you're like, wait, how do we do views? We haven't gotten to it yet. So I've truncated how I do the code, and it just works better this way. So you guys have 3 weeks where it's just working on your final projects. So we won't have official meetings on those Tuesday nights unless someone says, "Hey, can we meet?" And if for those of you who are watching and it's not Tuesday night, it's like Thursday afternoon. If you ever need to meet with me for your final project, and this goes for you guys too, you can arrange a time with me because my work computer is over there. This is over here. And if you need me or something, I can just turn around for 20 minutes and chat with you guys whenever. Just remember that I'm on Eastern time. So whenever you guys need to meet up, just text me and say I want to meet at this time. Don't ask me what's good for me. Just tell me when you're going to meet and I'll be there. And if I can't, I'll tell you. Because if like you'll say, hey, can we meet? I'll say, hey, when's good with you? And you'll go back, how about Thursday? And we'll go back and forth for a while. It's just easier to say, can you be here at 3 o'clock? Yeah, sure. And if I can't, I'll just, because my job over here is pretty, I can step away from it when I need to come over here. Because all I gotta do is literally, hello, I'm back. All right. All right. So I'm pretty sure next week is views and stored procedures, and the week after is indexes. Views and stored procedures. Yeah, that's right. So views and stored procedures you need for final project. Indexes is just something I'd like to talk about. So they're mentioned. I think week 12 is indexes. Week 12 is indexes and week 13 is views, and we never talk about stored procedures, but I'm going to. So indexes are the least important that we're talking about because it's not final project related. But it's something good to understand how they work. So if there are no other questions, I will release you into the wild until next week at 9:30 my time. All right? Okay, guys. Thanks for coming tonight. I'll talk to you guys later.